In lesson 16, we're going to continue graphing, and it is another major lesson, so let's go ahead and get started. Instead of graphing three different objects that are moving at different speeds, each of these objects will be moving at the same speed, but they'll have different starting points, and we'll see what that looks like. So here's box A. At 5 miles per hour, how far will a bicyclist go in 4 hours? Use D equals R times T. So here's D equals R times T. Go to the next line. The rate is 5 miles per hour. So write down 5 miles per hour times the time is 4 hours. So write down 4 hours. Your eyes should immediately see that you can cancel out hours and hours. Take care of the numbers. 5 times 4 is 20. Take care of the units. We have miles. So the distance is 20 miles, and that answers the question, how far? Let's go ahead and put this into the graph. This is the y-axis. Here on the bottom, we have the x-axis. And we're measuring distance using miles. This is time measured in hours. So according to box A, in 4 hours, bicyclist A went 20 miles. Here is 4 hours and 20 miles. Once again, this bicyclist started at 0, so I'll draw a point there. And now let's use a straight edge to connect these two dots. Here's my ruler. Touch, touch, and adjust, and connect the dots. So this is bicyclist A. And bicyclist A was going 5 miles per hour, so I'll write that down. 5 miles per hour. Next, let's go to bicyclist B. Here, a second bicyclist is going 5 miles per hour as well, so it's going the same speed as bicyclist A, but she has a 10-mile head start. It says, without doing any calculations in this box, graph the equation. So let's go ahead and do that. So here, bicyclist B didn't start at 0. She had a 10-mile head start. So in the graph here, instead of starting at 0, she had a 10-mile head start. So I'll put a dot right there. And how fast was bicyclist B traveling? As you see here, bicyclist B was going 5 miles per hour as well. So in my graph, starting at 10, we'll go up 5 miles per 1 hour, and draw a dot there. 5 miles per hour, 5 miles per hour, 5 miles per hour. And I think I have enough dots to draw a line now, so let's go ahead and do that. Here is my straight edge. I'll choose this dot here, touch it with my ruler, and adjust, and connect the dots. So this is bicyclist B, who was also traveling at 5 miles per hour. Finally, let's go to box C. A third bicyclist is going 5 miles per hour as well, but he has a 15-mile head start. Without doing any calculations in this box, graph the equation. So we have a 15-mile head start, and this bicyclist is going 5 miles per hour. Here, the bicyclist didn't start at 0. He started at 15 miles. So I'll draw a dot here. And remember, he was going 5 miles per hour. So we'll go 5 miles per hour. Draw a dot there. 5 miles per hour. 5 miles per hour. 5 miles per hour. And again, I think I have enough dots to draw the line. So I'll use my straight edge. I'll use this dot here. Touch it with my ruler and adjust. And here is my line. So this is bicyclist C, who is also going 5 miles per hour. Let's take a closer look at the graph and see if we can make some observations. So here's bicyclist A, who is going 5 miles per hour. Bicyclist B was also going 5 miles per hour. And bicyclist C was going 5 miles per hour as well. And you can tell that all three of them were going at the same speed because they're making parallel lines. So A, B, and C are parallel to each other because they have the same speed. Now let's go ahead and write the equations for each of these lines, starting with bicyclist A. So here is bicyclist A, and the formula that we used for bicyclist A was right here, D equals R times T. So right here, I'm going to write down D equals R times T, just like we did in lesson 15. And the rate here was 5 miles per hour. So instead of writing D equals R times T, I'm going to write down D equals 5 times T. D equals 5T. Now take a look at D for distance, right here. What axis is it on? And you can see it's on the y-axis. So I'll write down y. Write down equals, bring it on to 5. And now look at T for time. Here it is. What axis is T on? And you can see it's on the x-axis. So I'll write down x. And now we have the formula, y equals 5x. So I'll go ahead and box that. Now that we've taken care of bicyclist A, let's look at bicyclist B. Here, bicyclist B was also going at 5 miles per hour. So I'm going to write down y equals 5x as well. Y equals 5x. But remember, bicyclist B actually had a head start. How much of a head start did bicyclist B have? Well, if you look in the problem, you can see that she had a 10-mile head start. So the equation isn't just y equals 5x. It's going to be y equals 5x plus 10. And where did that 10 come from? Well, that is just the head start that bicyclist B received. So I'll go ahead and box it. The equation for bicyclist B is y equals 5x plus 10. And you can see that this 10 here also shows up on the graph. Here is the head start for bicyclist B. So I'll go ahead and write down head start. Now for bicyclist C. Bicyclist A was y equals 5x. Bicyclist B was going at the same speed but had a 10-mile head start. So the formula was y equals 5x plus 10. What do you think the formula is for bicyclist C? Bicyclist C was also going 5 miles per hour but had a 15-mile head start. So instead of y equals 5x plus 10, the formula for bicyclist C is going to be y equals 5x plus 15. Go ahead and box that. And where did that 15 come from? That is just the head start that we saw in the problem. And you can see it on the graph as well. If you trace it back, there's the 15-mile head start that bicyclist B received. So I'll go ahead and write it down. Head start. Now in math terms, the head start is known as the y-intercept. So right here, where I wrote head start, I'll just write down y-intercept. And that just means where this line crosses the y-axis, which is right here. So taking one last look, the y-intercept or head start for this line is 15. The y-intercept or head start for this line is 10. And the y-intercept or head start for this line is 0.